right, so this is going to be section 5.3, which should be hopefully shorter than the last couple lectures. There isn't anything new in this section. We're just going to do some repeat styles of problems that are going to be slightly more complex because the problems in this section are going to have i's, which make them a little bit harder to work with. And because of the I grunginess and because my calculator can do i's, I need to get my calculator set up to handle this particular section. And the setup that I'm going to do, I can just leave. This setup is going to be good for whether we're working with i's or not. So right now you should have your calculator, TI-83 or 84, if that's what you're using, out. Hit the mode button, and then you'll see it says normal float, radian function, connected dot, sequential, real, and that right now my cursor is flashing where it says real. I want it to be flashing where it says a plus bi, and I want to hit enter. So I should, if I pull off that line, have the a plus bi darkened. Having that set up, instead of having the real darkened, having the a plus bi darkened will make some of the grunge of this section able to be done on our calculator. So you'll definitely want to have that set up. It'll save quite a bit of time and probably keep you from making mistakes. Let me just jump right into the section and see how that goes without any kind of warm-up like I sometimes do. So this particular problem, or the first 10 problems, want me to create functions with a 1 as the lead coefficient that satisfies this condition. So ultimately, I'm going to come up with an equation that says f of x. It has to be a third degree polynomial. There has to be a 1 in front of the x cubed. So it's going to be x cubed and then a bunch of other things after the x cubed, so that if I plug negative 5 in for x, I get 0, and if I plug 3 plus I in for x, I get 0. So my goal is to find something that I can plug negative 5 and 3 plus I in and get 0. And this answer is not going to have any i's in it. This isn't terribly hard. So I'm going to start off by writing f of x equals, and for each of the zeros, or x-intercept, that I'm given, I'm going to subtract it. So I'm going to make the first 0 of negative 5 a factor of x minus negative 5. The second 0 of 3 plus I, x minus 3 plus I in a parentheses. And if I multiplied that out, I'd only get an x squared. I wouldn't get an x cubed. It turns out that if you have a 0 with an I, its conjugate, which means the same complex number with a different sign, is also a 0. So the fact that 3 plus I is a 0, I know that 3 minus I is a 0, and I'm going to make a third parentheses with an x minus this 3 minus I. If I multiply these out, all the i's are going to cancel amazingly, and I'm going to get a polynomial that if I plug negative 5, 3 plus I, or 3 minus I in for x, that it'll reduce to 0. And I'll show you that in a second after I do the grungy math. So I'm going to start off by getting rid of the colored parentheses. I'm going to make this f of x the first parentheses. I'm going to just make it an x plus 5. The double minus goes to a plus. In the second parentheses, the minus is going to distribute through, and I'm going to get an x minus 3 minus I. And in the last parentheses, the minus is going to distribute through, and I'm going to get an x minus 3 plus I. I need to FOIL everything out. I'm going to start off by FOILing these two parentheses, or multiplying out these two parentheses. I'm going to leave myself some room to do that. So I'm going to get something eventually that says x plus 5 times something that could be rather lengthy. It's what I get when I multiply these two trinomials out. So to do these multiplications, I'm going to do it in a different color just so it stands out. I'm going to take this x and multiply it by each of the 3 items in the parentheses that it's next to. So I'm going to take the x, multiply it by an x, the x, multiply it by a negative 3, the x and multiply it by a positive I. That's going to give me x squared minus 3x plus, and I can write ix or xi, it doesn't matter. Do the same thing with the negative 3 in the left parentheses. I'm not dealing with the x plus 5 parentheses at the moment. I take this negative 3, multiply it by the x, the negative 3, and the I. I'm going to go negative 3 times x, negative 3 times negative 3, and negative 3 times positive I. When I do that, negative 3 times x I'm going to write as negative 3x. Negative 3 times negative 3 I'm going to write as a plus 9. And negative 3 times I I'm going to write as a negative 3i. So I'm done with this x, I'm done with that negative 3. I'm going to work with the negative I and multiply it by each of the 3 items in the parentheses that it's next to. So I'm going to go negative I times x, negative I times negative 3, and negative I times positive I. The negative I times x I'm just going to write as the negative ix. The negative I times negative 3, that's two negatives. I'll multiply to be a positive, and I'll write the I and the 3 next to each other. And then the negative I and the positive I I'm going to write as negative I squared. I want to simplify, and when I do this multiplications, things cancel. This ix, it's a positive ix, and that negative ix are opposites. They're going to cancel. Similarly, this negative 3i and that positive 3i are opposites, and they cancel. What doesn't cancel is I have an x squared minus 3x minus 3x, a plus 9, and then a minus I squared, but I squared I can replace with a negative 1, so a minus negative 1. So after I cancel, I have x squared minus 3x plus 9 minus negative 1. I'm going to simplify that. The x squared, I'm going to leave x squared. The minus 3x and the minus 3x, I'm going to write as a minus 6x. And this 9 minus a negative 1 is really 9 plus 1 because a double negative goes positive. So that's 9 plus 1, which is a positive 10. So now I have this multiplied out to the point where I don't have i's, which is a good thing, but I don't have an x cubed. I'm going to get the x cubed by doing this multiplication. That's multiplying x by everything in the parentheses next to it, and 5 and everything in the parentheses next to it. I'll color code that. So I'm going to go x times x squared, x times minus 6x, x times 10. When I do that, x times x squared is x cubed. X times minus 6x is minus 6x squared. X times 10 is a plus 10x. I'm going to work with the 5. I'm going to go 5 times x squared, 5 times minus 6x, and 5 times 10. When I multiply the 5 times x squared, I get a 5x squared. I'm going to write it right under the minus 6x squared because those are the terms I'm going to need to combine. The 5 times the minus 6x gives me a minus 30x. I'm going to write that right under the plus 10x because those are terms that need to be combined. And the 5 times the 10 gives me a 50, a positive 50. So I'm going to combine like terms. The x cubed is going to remain. The negative 6x squared plus 5x squared gives me a negative x squared. The 10x minus 30x gives me a minus 20x. And the plus 50 is a plus 50. I'm done. Now I'm going to show you how to check your answer via your calculator. For this answer to be correct, it's definitely a third degree polynomial. It should be the case that when I plug negative 5 in for x, or if I plug 3 plus I in for x, or if I plug 3 minus I in for x, I should get 0. If I don't get 0 when I plug those things in, then I've messed up. So let me just do the checking, and I'll do the 2 parts of the checking. I won't check all 3. So my answer that I came up with was x cubed minus x squared minus 20x plus 50. It's supposed to be the case that if I plug negative 5 in, so if I go negative 5 cubed minus negative 5 squared minus 20 times negative 5 plus 50, it's supposed to be the case that I get 0. If I don't get 0, then negative 5 is not a 0 and I made a mistake. So let me check. I'll just use my calculator because I don't care to do this without my calculator. So I turn my calculator on and go parentheses negative 5 cubed minus negative 5 squared minus 20 times negative 5 plus 50. If when I hit enter, I don't see 0, then I know I've made a mistake and I need to find it. So I'm going to hit enter. It says 0. Beautiful. That's not guaranteeing me to be right. It also has to be the case that if I put 3 plus I in for the x, and I go 3 plus I cubed minus 3 plus I squared minus 20 times 3 plus I plus 50, it also has to be the case when I do that I get 0. So it'd be horrible to do by hand, not so horrible on my calculator, since my calculator is going to do i's. So I'm going to start this off. I'm going to go 3 plus, and then you have to find the I. The I is located on the decimal. I hit second in the decimal, and it gives me an I. So there's my 3 plus I, then up arrow cubed, and then minus, parentheses, 3 plus second decimal for the I, squared, minus 20 times parentheses 3 plus second I plus 50. So I claim that that's entered that properly. And if I don't see 0 when I hit enter, that means I made a mistake, because 3 plus I is supposed to be a 0 of a function. To be a 0 of a function, when you plug that value in for x, you get 0. I hit enter and it's 0. I'm going to hope that the 3 minus I works. I don't think it's even possible for the 3 plus I to give you 0 and the 3 minus I not to give you 0. So I'm not going to fully check just to save a minute. But you could do the same thing with the 3 minus I. You can do 3 minus I cubed minus 3 minus I squared minus 20 times 3 minus I plus 50. It should also equal 0. So the grunge is the multiplying out to get to your answer. Each one of the first 10 problems I'm going to do exactly the same way. I'm going to come up with as many zeros as I need. I need a degree 3 polynomial. I have 1 0 of 7, 1 0 of 2 minus I. Anytime I have a 0 with an I get another 0 by changing the sign in front of the I. So 2 plus I is going to be my 0. My polynomial is going to be f of x equals x minus 3 times. I need a third degree polynomial, so I have to have 3 factors. The first one I'm going to have an x minus 7. The second one I'm going to have an x minus 2 minus I. And the third one I'm going to have an x minus a 2 plus an I. The 7 I didn't need to put in a parentheses because it was just one number and it wasn't negative. My answer is going to be f of x equals x cubed, and then there's going to be a bunch of junk after the x cubed that I can't quite predict yet, but I'll get to it in a second. To get to it, first parentheses I'm going to leave at x minus 7. Second parentheses, I distribute the negative and get x minus 2 plus I. Third parentheses, I drop the colored parentheses and get x minus 2 minus I. And just like I did in the last problem, I'm going to multiply out the parentheses with the i's first. Leave the x minus 7 alone for a little bit. I'm going to put whatever this multiplies out to next to the x minus 7. I need to do 9 multiplications. First, I take the x, multiply it by all 3 things. So I'm going to go x times x, x times minus 2, and x times minus I. X times x is x squared, x times minus 2 is minus 2x, x times minus I is minus ix. Do the same thing with the minus 2, multiply the minus 2 by the x, the minus 2, and the I. So I go minus 2 times x, minus 2 times minus 2, minus 2 times minus I, minus 2 times x gives me a minus 2x, minus 2 times minus 2 gives me a plus 4, minus 2 times minus I gives me a plus 2i. And now I'm going to do the same thing with the I. I'm going to multiply the I by the x, the I by the negative 2, and the I by the negative I. When I multiply the I times the x, I just get a plus ix. When I multiply the I times the negative 2, I get a negative 2i. When I multiply the I by the I get a minus I squared. Just like in the last problem, most of my i's are going to cancel. The negative ix and the positive ix are opposites, they cancel. The positive 2i and the negative 2i are opposites and they cancel. What I have left is x squared minus 2x minus 2x plus 4, and then minus I squared, but I'm going to change the I squared to a -1, so minus -1. And combine like terms there, I leave the x squared. The two x's have the same sign, so it's combined to a minus 4x. The 4 minus a -1 is really 4 plus 1, and I'm going to get a plus 5. I's are gone. I need to get my x cubed. I'm going to get my x cubed by finishing up the multiplication. I'm going to take the x, multiply it by all three things, and the minus 7 and multiply it by all three things. So I'm going to go x times x squared, x times minus 4x, x times 5. That will give me x cubed minus 4x squared plus 5x. Do the same thing with the minus 7. I'll go minus 7 times x squared minus 7 times minus 4x and minus 7 times 5. Minus 7 times x squared is minus 7x squared. I'm going to stack it so I can combine easier. Minus 7 times minus 4x is plus 28x. And then minus 7 times positive 5 is minus 35. What I'm left with, when I combine the like terms, is going to be my answer. X cubed, both negatives in front of the x squared gives me a negative 11x squared. 28 and 5x gives me a plus 33x, and then a minus 35. And let me just check this with 7. I'm going to plug 7 in and see if, well, let me plug 2 plus I in. I'm going to plug 2 plus I into that and see if 2 plus I cubed minus 11 times 2 plus I squared plus 33 times 2 plus I minus 35. See if I get 0. If I get 0, I probably am right. If I don't get 0, I probably made a mistake. So let me try that the best I can. So I don't know if it's at a good spot. So I'll go parentheses 2 plus second I up arrow cubed minus 11 times parentheses 2 plus second I squared plus 33 times 2 plus second I minus 35. I think that's perfectly entered. It's going to be correct, at least partially checked, if I hit enter and I get 0, which I do. I should, if I wanted to be 100% sure, do the same thing with the 7 and the 2 minus I. But I think if I get something that nasty to work, the other ones are just going to work. So I'm not going to check it out all the way. But this is all you have to do. You don't have to check, but it takes about 30 seconds to check one of the numbers. If you check the one with the I and it's right, then the chances of you having the wrong answer are pretty slim. I want a degree 4 polynomial for number 6. It's going to be quite a bit harder. My answer has to look like f of x equals x to the 4th, and I need a bunch of junk after the x to the 4th, which means my starting needs to have 4 different parentheses and x minus 4 different things to get a 4th degree polynomial. If I look in my initial problem, I don't see 4 unique items, but I know that if 3i is a 0, so is negative 3i, and if 4 minus I is a 0, so is 4 plus I. So I'm going to make up in my first parentheses an x minus 3i, in my second parentheses an x minus negative 3i, in my third parentheses an x minus 4 minus I, and in my fourth and last parentheses x minus 4 plus I. I'm going to get rid of, this is supposed to be, that is just 3i, that's fine. I'm going to try to clear out the parentheses, the colored parentheses. I'm going to get f of x equals to the first x minus 3i won't change. The second I have a double negative, it's going to go to x plus 3i. That's actually going to be easy to multiply those two. And then x minus 4 plus I and x minus 4 minus I. Let me do the grungy multiplication again. And I'm going to save some room to do, this is an easy multiplication. But let me get the hard part out of the way. Let me do this multiplication. So I'm going to go x times x, x times minus 4, and x times minus I. That gives me x squared minus 4x minus ix. Start with the minus 4. Go minus 4 times x, minus 4 times minus 4, and minus 4 times minus I. Minus 4 times x is minus 4x. Minus 4 times minus 4 is positive 16. Minus 4 times minus I is plus 4i. Now I'm going to deal with the I and go I times x, I times minus 4, and I times minus I. I times x I write as a plus ix. I times minus 4 I write as a minus 4i. I times minus I get minus I squared. Things will cancel. This is a plus ix and a minus ix. These are going to cancel. And similarly, this plus 4i and that minus 4i are going to cancel. So what I have is x squared minus 4x minus 4x plus 16, and then minus I squared, and I squared is a negative 1. So combining those terms, I get x squared minus 8x plus 17. The I parts that I haven't dealt with yet, because those are opposites or conjugates, I only have to do the firsts and the lasts. The outers and the inners are going to cancel. So if I did full out foiling for the first two items, the x minus 3i and the x plus 3i, the outers and the inners would cancel. So I don't really have to FOIL them. I'm just going to do firsts and lasts. First are x times x, which is an x squared. Last are negative 3i times positive 3i. That's negative 9i squared. That's really negative 9 times negative 1, which is plus 9. So I get f of x equals x squared plus 9, that's negative 9 times negative 1, times x squared minus 8x plus 17. Now I just need to multiply this out. I'm going to take the x squared, multiply it by the 3 items in the parentheses next to it, and do the same with the 9. So I'm going to go x squared times x squared times minus 8x, and x squared times 17. You know, I don't know where to put that. This gives me x to the 4th minus 8x cubed plus 17x squared. And then I do with the 9. I go 9 times x squared, 9 times minus 8x, and 9 times 17. 9 times x squared is plus 9x squared. 9 times minus 8x is minus 72x. And 9 times 17, I'm not going to attempt to do, is 153. Plus 153. The only like terms that can be combined are these squared terms right there. So the x to the 4th and the minus 8x cubed are stuck there. 17x squared plus 9x squared is 26x squared. The minus 72x and the plus 153 just hang out and don't get multiplied by anything. Let me check one of these horrible ones, like the 4 plus I, and see to make sure that if I go 4 plus I to the 4th minus 8 times 4 plus I cubed plus 26 times 4 plus I squared minus 72 times 4 plus I plus 153. I'm going to enter that in my calculator. If I get 0, I'm going to gamble that the other three items up there are also going to work. It's not guaranteed, but I don't feel like checking 4 things. But I can check one, and it doesn't take that long, and I might as well check an ugly one because I'm more likely to make a mistake with the ugly ones. So I'm going to go parentheses 4 plus second I to the 4th power minus 8 times 4 plus second I to the 3rd power plus 26 times parentheses 4 plus second I squared minus 72 times 4 plus second I plus 153. And boy, there's certainly a lot of room for error in this, so I hope that when I hit enter I see 0. If I don't see 0, my options are hunting through my work to find the error or just redoing the problem. Beautiful, it gave me a 0. More often than not, I just start the problem over. If I would have hit enter and not seen a 0 there, I probably would have just threw this out and started over because I have a hard time finding my own mistakes. I should technically do the same thing with 4 minus I, 3I, and negative 3I to be 100% sure that my answer checks. Just checking one of the 4 zeros to make sure it works isn't technically enough, but in reality, if one works, the probability that you made a mistake is pretty low. So I'm gambling that that's okay. 8 also wants a 4th degree polynomial, but it has nice zeros. It doesn't have any zeros with a minus. So I'm going to do, with the 3i, I'm going to pair it up with a minus 3i. The 7i, I'm going to pair up with a minus 7i. My polynomial is going to have 4 parentheses to start. I'm going to have an x minus 4 times. This is way nicer than anything we've done so far. And I can do x minus 3i, x minus negative 3i, x minus 7i, and x minus negative 7i for my 4 factors. Get rid of the parentheses. Notice I didn't put a parentheses where I didn't have a double negative, so I get x minus 3i, x plus 3i, x minus 7i, x plus 7i. And when I go to FOIL this out, I'm going to FOIL these two separately from these two to start. So the first go around, I'm going to multiply those two together into 1 and these two together into 1. Because they're conjugates, you only have to do the first and the last. The outers and the inners will cancel. So doing the first here, x times x is an x squared. Skipping the outers and the inners because they're going to cancel anyways. Doing the last, negative 3i times positive 3i, negative 9i squared. Same with the 7i's. Doing the first, x times x is x squared. Negative 7i times positive 7i is negative 49i squared. Now I'm going to replace my I squareds with negative 1. So in the first parentheses, I really have minus 9 times minus 1. In the second parentheses, I really have minus 49 times minus 1. So I can write this as x squared plus 9, getting rid of that double negative, times x squared plus 49. Now I'm going to FOIL this. Firsts, x squared times x squared. Outers, x squared times 49. Inners, 9 times x squared. Last, 9 times 49. And I get f of x equals x to the 4th plus 49x squared plus 9x squared. And then I don't want to gamble on 9 times 49 in my head. It's 441 plus 441. Combine those terms and I get my answer of f of x is a 4th degree polynomial, 1 in front of the x to the 4th. X to the 4th plus 58 x squared plus 144. Check it. I'm going to put a 7i into that and see that it works. So without really even writing anything down, I'm going to go parentheses 7 second I to the 4th power plus 58 times 7 second I squared plus 144. It better say 0 when I hit enter, and it doesn't say 0. That tells me either A, I entered something wrong on my calculator, B, I have a mistake because it didn't say 0. So it's actually good that I made a mistake because now I can sit down and find it. It's 49 and 9 is 58. I wrote 4, instead of 441, I wrote 144. This should be 441. This is an easy mistake, hopefully. And let me recalibrate this and do 7i, 7 second I, up arrow 4th, plus 58 times 7 second I squared, plus 441. Hit enter. And I get this. This certainly doesn't look like 0. Negative 1e to the negative 10. My calculator does funny things with I to the 4th power. And this negative 1e to the negative 10, this means 9. It means a negative, a decimal, 9 zeros in a 1. There's 9 zeros and a 1 to the right of the decimal. Although that doesn't say 0, that certainly rounds to 0. So when I get an E with a negative, like a high negative number, that's my calculator not really being able to do algebra and doing some sort of algorithm that mimics the algebra. And this is close enough to 0 for me to believe I'm correct, because it's negative 0.9 zeros and a 1, and I don't know if that's 1 trillionth or less than 1 trillionth. So it's a really small number. For all practical purposes, that's 0, and I'm going to say that I'm correct and not check this by hand, which would be an utter, really uncomfortable nuisance to do. And the last degree 4 one. I need 4 zeros, 3 i's is 0, so negative 3i is going to be another 0. I'm going to get f of x equals to x minus, and I need 4 x minuses. One of the minuses is going to be a negative 3i. One of the minuses is going to be a plus 3i. Another minus is going to be a 5, and the other one's going to be a negative 6. It doesn't matter the order that I put them in, but I kind of didn't have room, so I might have put them in a different order than you. It doesn't matter. So I have x minus a negative 3i, which I'm going to change out that double negative and make that x plus 3i, and then an x minus 3i, and then an x minus a negative 6, which I'll write as an x plus 6, and then an x minus 5. Foiling this out, I'm going to FOIL those out first because they're easy to FOIL. I do the firsts. X times x is x squared, and the last 3i times minus 3i is minus 9i squared. That minus 9i squared is minus 9 times a negative 1, which is a positive 9. So I get f of x equals to x squared plus 9 times x plus 6 times x minus 5. Now I just go left to right and figure out my multiplication. So I'm going to multiply these two parentheses. I'm going to go x squared times x squared times 6, 9 times x, 9 times 6, and that's going to give me an x cubed plus a 6x squared plus a 9x plus a 54. Done with the x plus 6 parentheses, still have the x minus 5 parentheses to deal with. Now I'm going to multiply everything in this parentheses by both x and 5. That's going to be 1, 2, 3, 4, 8 multiplications. So I'm going to go x cubed times x cubed times minus 5, x cubed times x is x to the 4th, x cubed times minus 5 is minus 5x cubed. Now I'll do the same with the 6x squared. I'm going to go 6x squared times x. That's a positive 6x cubed. I'm lining it up so I can see the canceling or the combining. And then I'm going to go 6x squared times a minus 5 and get a minus 30x squared. I do the 9x now. I'm going to go 9x times x, and I get a plus 9x squared. And then 9x times minus 5 is minus 45x. And then I'll do the 54. I'll do 54 times x and I'll get a positive 54x. And then 54 times minus 5. Dangerous to do that without a calculator. 54 times minus 5 is minus 270. I tried to set this up so I can see the combining. The x to the 4th is going to stay, so I'm going to write my answer up top because I don't have a lot of room here. The x to the 4th is going to be part of my answer. The negative 5 and the positive 6x cubed, so that's an x to the 4th, believe it or not, gives me a positive 1x cubed, or just a positive x cubed. The minus 30 and the plus 9x squared gives me a minus 21x squared. The minus 45 and the positive 54x, minus 45 plus 54 gives me a positive 9x. And the minus 270 hangs out. I claim that this is the answer. I can take any one of the numbers and plug it in, 3i negative, 3i 5, or negative 6. I'm going to plug 3i in. Might get something with that ugly notation, but let me check this. I'm going to go 3 second I to the 4th plus 3 second I cubed minus 21 times 3 second I squared plus 9 times 3I minus 270. I believe I've entered that properly. When I hit enter, I didn't enter it properly. I've got a floating parentheses here. Next to that 3I, there's supposed to be a 9 there. Now I hit enter, and it gives me 0, so I'm pretty sure that answer is correct. So that's the first 10 problems. They're all kind of the same. They're grungy because they have a lot of multiplication to do, but it's not horrible. Similarly, I'm supposed to ask you in problem 12 to solve this problem. Solve x cubed plus 3x squared plus 25x minus 75 equals to 0, although the problem doesn't have the equal to 0, and this 14 doesn't have the equal to 0. 16 does have the equal to 0. Who knows why I didn't put it there, but I'll insert this before you print it out. So I'm trying to solve that problem. I'm going to solve it by factoring, and I'm going to use synthetic division for my factoring. And usually when I have a cube, I only do single synthetic division. I'm going to do synthetic division with an I, and that's going to cause me to do double synthetic division. So I'm going to use the fact that x equals 5i as a solution. That means I'm going to divide by x minus 5i. Let me do that. And let me dig out another sheet of paper. I think I need more room than I'm leaving myself here. So I'm solving this problem. X cubed plus 3x squared plus 25x plus 75 equals to 0. That's what I'm attempting to solve. I know that 5i is a 0, or 5i is a solution. Because 5i is a solution, negative 5i is also a solution. I'm going to divide by x minus 5i and x minus negative 5i, which is the same as x plus 5i. So I'm going to do double synthetic division. The answer that I get is going to help me factor the x cubed plus 3x squared plus 25x minus 75. And very specifically, I'm dividing by x minus 5i, x minus a negative 5i, which is the same as x plus 5i. When I get done with my double synthetic division, I'm going to have a way to completely factor this polynomial. In general, I'd have no idea how to factor this, especially because the factoring has i's. Never have I just factored with i's before, but synthetic division allows you to factor with i's. So I'm going to come up with 3 polynomials that if I multiplied them back out, they'd equal this polynomial, and they're going to give me solutions to the problem. To be a solution, when I plug the number in, I should get 0. I'll show you that 5i is a solution, because when I plug 5i in, if I do parentheses 5 second I up arrow cubed plus 3 times parentheses 5 second I squared plus 25 times 5 second I plus 75. When I put 5i in, I get 0, so it's a solution to this problem. Also, if I plug negative 5i in, I get 0 because it's a solution to this problem. There's one more solution that I need to find. Synthetic division is going to help me get that solution. So double synthetic division. I'm going to start off with 1, 3, 25, and 75. And I can pick either one of these solutions. Let me take the 5i. This is grungy. I'm going to pull this on another sheet of paper because it's going to get too messy. So I need lots of room to do this. So I'm going to do this synthetic division. 1, 3, 25, 75, 5i in this little hook. Bring down the 1. Multiply 5i times 1 is 5i. Add. I don't know how to add 3 plus 5i, So I'm just going to write 3 plus 5i next to each other. Next multiplication I have to do is I have to take 5i times 3 plus 5i. I'm going to be dumb and do it on my calculator. So I'm going to go, this multiplication is 5i times 3 plus 5i. And when I do that, I get negative 25 plus 15i. So under the 25, I'm going to write negative 25 plus 15i. The 25s are going to cancel. When I add those together, I'll be left with a 15i. Now I need to multiply 5i times 15i. Use my calculator again. So I'm going to go 5i times 15i. When I do 5 second I times parentheses 15 second I get negative 75. That gives me a remainder of 0. That's the first synthetic division with the positive 5i. Grungy, but not horrible with my calculator. Now I need to use the negative 5i, which is the other 0 that I know, and do my synthetic division. Take the answer there without the 0 and the other 0, negative 5i, bring down the 1. Now I'm going to multiply 1 times negative 5i. I don't need a calculator to do that. 1 times anything is itself. So 1 times negative 5i is negative 5i. When I combine these together, the 5i's cancel and I have a 3. When I do this, negative 5i times 3, I get negative 15i. Those come out to be 0. I started with a third degree polynomial. I did double synthetic division. My answer needs to have 2 powers lower than 3. 2 powers lower than 3 is x to the first power. The result of my synthetic division is x to the first power plus 3 with remainder of 0. So my answers are going to come here in a second. I'm going to take this x plus 3 and get back to where I was working in the original mode. What the double synthetic division gave me, when I did 5i, that gave me x minus 5i as a factor. When I did negative 5i, that gave me x minus 5i or x plus 5i as a factor. And the result of my synthetic division was x plus 3 with a remainder of 0. That gives me the third and final factor. If I had the patience and wanted to treat this problem just like it was a problem that I was doing previously, I could multiply this out. It's going to multiply out to be that. So now I have it factored and set equal to 0. I can solve the problem. I solve the problem by setting each factor equal to 0. I'm going to go x minus 5i equal to 0, x plus 5i equal to 0, x plus 3 equal to 0. For the x minus 5i, I add 5i to both sides and get 5i as a solution. For the x plus 5i, I minus 5i from both sides and get minus 5i as a solution. For the x plus 3, which is the extra bit that came from my double synthetic division, I minus 3 from both sides and get x equal to negative 3. I say the answers to the problem that I had to add the equal 0 to are 5i, negative 5i, and 3. Let me check the 3. I checked the 5i already. I'm going to check the 3 to make sure when I plug it in there I get 0. So if I do this and go parentheses 3 up arrow cubed plus 3 parentheses squared plus 25 times 3 plus 75, I have to get 0 for 3 to be a solution. And I messed up, and it's good. I'm going to get an error right here. When I hit enter, it says 204. So 3 is not an answer. I made a mistake. I just caught my mistake. When I had x plus 3 equal to 0, I was supposed to minus 3 from both sides. So minus 3 should be the solution. So it was good that I checked because I blew it, and I should be checking minus 3. Specifically, I should be going parentheses minus 3 up arrow cubed plus 3 times minus 3 up arrow squared plus 25 times minus 3 plus 75. Because negative 3 is a solution, I should get 0. Positive 3 wasn't a solution, so I didn't get 0. And you made an error. And I used the wrong negative. Hopefully, and I get 0. Perfect. So 3 is a solution. I already checked one of the i's. The other I will check similarly. So the answer to this problem is just the solutions. It's a third degree polynomial. I hope to get 3 solutions. They're 5i, negative 5i, and negative 3. Got the third solution by synthetic division. The first 2 solutions kind of came for free. Okay, and that was all just problem 12, wasn't it? Yes, it was. It was just, I just didn't do it on the main sheet because I didn't think I had enough room. So similarly, I'm going to be short on room for 14. And similarly, I didn't write down what I'm solving. I'm solving 3x to the 4th plus 5x cubed plus 25x squared plus 45x minus 18 equals to 0. Because 5i is the solution, I'm going to do synthetic division with 5i. If 5i is the solution, so is negative 5i. When I do my double synthetic division, it's going to give me a way to factor 3x to the 4th plus 5x cubed plus 25x squared plus 45x minus 18. And specifically, one of the factors is going to be x minus 5i. The other factor is going to be x minus negative 5i, which is really x plus 5i. And then the result of the double synthetic division is going to go there. So I'm going to do double synthetic division, once with negative 5i, once with 5i. And it's going to tell me that this whole polynomial factors into x minus 5i times x plus 5i, because that double negative factors into, the double negative goes positive, and then times something else. I'll get that something else. I can't know what it is right now. First synthetic division, I'm going to go 3, 5, 25, 45, minus 18. And I could do positive or negative 5i. I need to do one of each. Let me get the negative out of the way, but you could do the positive first. Bring down the 3. Now multiply 3 times negative 5i. That gives me a minus 15i. I don't need a calculator yet. Adding these two, I just write them next to each other and get 5 minus 15i. Now I'm going to use my calculator. I'm going to multiply minus 5i times 5 minus 15i. And I don't want to do that multiplication without my calculator. So I'm taking negative 5 second I times parentheses 5 minus 15i. And when I do that multiplication, I get what's going to go up there, which is negative 75 minus 25i. The negative 75 and a positive 25 give me a minus 50 minus 25i. Yuck. Now I'm going to multiply negative 5i times negative 50 times minus 25i. So I go negative 5 second I times minus 50 minus 25 second I. This is a real nuisance to do with a calculator, much more without a calculator. When I do this, I'm getting worried. I get minus 125 plus 250i, so I get minus 125 plus 250i. The minus 125 and the 45 are going to give me a minus 80. Minus 125 plus 45 gives me a minus 80. So I get minus 80 plus 250i. I'm worried that either I have a mistake or I have a problem that's not right, but I'll keep going here and see what happens. Lastly, I need to go minus 5i times that. So I'm going to go minus 5 second I times, back up, times minus 80 plus 250i. And I don't get positive 18. Let me do 2 things. First of all, make sure this problem actually is good, that 5i is a solution. To make sure that 5i is a solution and I have a problem that actually works, I'm going to plug 5i in for these x's and make sure I get 0. If I don't, then the problem was bad to start, and this is what happens when you're a bit lazy and you open up an old college algebra textbook and you copy down problems and potentially don't copy the problem down right. So what I'm doing now is before I check for an error in my math, I'm checking for an error in the problem. And real specifically, it should be the case that if I plug 5i in for the x or minus 5i in for the x, when I hit enter I get 0, and I don't. So I plugged 5i in for the x, and I didn't get 0. So this means I did something horribly wrong when I copied the problem from another text, and I can't do this well enough in my head to recover this problem to make a problem that works. So this is a good learning experience that I can tell when something is or isn't a solution. Something's a solution, you have to get 0 for a remainder. If I don't get 0 for a remainder, then either it's not a solution or I made a mistake. I check to see if it was a solution, it's not a solution. I'm just gonna, for right now, let's say skip this. I might make up a new problem 14 and put it in the homework, or I might just do this to this problem and never look at it again and not figure out the fix. The idea was good. I had all the right thoughts, but it just I don't have the right answer, and I don't know how to get the right answer without doing something tricky or something I can't do that quickly. Let me make sure that 1 plus 3i is a solution to problem 16 before I actually do problem 16. So I'm going to make sure that 1 plus 3i to the 4th power minus 7 times 1 plus 3i cubed plus 14 times 1 plus 3i squared minus 38 times 1 plus 3i minus 60. I'm going to make sure that that equals 0, because if that doesn't equal 0, then my synthetic division is just going to fail me. So let me do this real quickly. Do 1 plus 3 second I to the 4th power minus 7 times 1 plus 3 second I to the 3rd power, forgot the up arrow, plus 14 times 1 plus 3 I squared minus 38 times 1 plus 3 I minus 60. And I get this negative 2e to the 11. That's 10 zeros and a 2. A decimal point, 10 zeros and a 2. That's 0. So 1 plus 3i does work. I'm going to do synthetic division, and I'm going to do double synthetic division. I'm going to do synthetic division by 1 plus 3i, and I'm going to do synthetic division by 1 minus 3i. And what that's going to give me the ability to do, it's going to give me the ability to take the original polynomial and get it factored into x minus 1 plus 3i, x minus 1 minus 3i, and something else that's the result of my double synthetic division. Need to do that double synthetic division on another page, probably one synthetic division per page. So I'm going to do synthetic division with 1 plus 3i, get a remainder of 0, do synthetic division with 1 minus 3i. The result of that second synthetic division is going to have an x squared in the answer, and that's what I'm going to put in this parentheses here to get this thing completely factored. So double synthetic division, one at a time. First thing I'm going to do is the 1 plus 3i, because that's what I checked. I'm going to pull off the coefficients of 1, negative 7, 14, negative 38, and negative 60, and put a 1 plus 3i in my little hook. Bring down this 1, and now multiply. I'm going to go negative 7 times 1 plus 3i. I'm going to be completely mindless and use my calculator a ton. So I'm going to go negative 7 times parentheses. I wish this was visible everywhere, times 1 plus 3i. That gives me negative 7 minus, whoops, I'm supposed to multiply by 1. Duh. 1 plus 3i times 1 is just 1 plus 3i. I was getting a little too cute there. Sometimes these problems your head starts to spin, they get so complicated, but always multiply what's on the bottom by that. So 1 plus 3i times 1 is 1 plus 3i. Now I'm going to combine this minus 7 and that 1 and get a minus 6 plus 3i. Now I'm going to multiply 1 plus 3i times minus 6 plus 3i. That I'm using my calculator for. So I'm going 1 plus 3 second I times negative 6 plus 3 second I, and that multiplies out to be negative 15 minus 15i, which I'm going to write right under that 14. And now I'm going to combine the positive 14 and the negative 15. When I combine those combine to be a negative 1, and I keep the minus 15i. Now I'm going to multiply 1 plus 3i times negative 1 minus 15i and write that under the minus 38. Again, all calculator here. 1 plus 3 second I times negative 1 minus 15 second I. You wouldn't want to do this without a calculator that does i's. This gives me 44 minus 18i, which I'm going to write right under that 38. I'm going to combine the 44 and the minus 38 and to get a positive 6. So that gives me 6 minus 18i. And the last multiplication I'm going to do was 1 plus 3i times 6 minus 18i. So I go parentheses 1 plus 3 second I, then parentheses 6 minus 18 second I. When I hit enter, it gives me a positive 60. So I get a remainder of 0. That's the first step of my synthetic division. Now I want to do synthetic division with the 1 minus 3i. So I'm going to take these pieces, the 1, the minus 6 plus 3i, the minus 1 minus 15i, and the 6 minus 18i, and do those synthetic division with 1 minus 3i. Bring down the 1. 1 times 1 minus 3i is just 1 minus 3i. This is nice because the i's cancel, and I get negative 6 plus 1 is negative 5. Now I'm going to multiply 1 minus 3i times negative 5. I'm going to go negative 5 times parentheses 1 minus 3 second I. And that gives me negative 5 plus 15i, which I probably could have done without my calculator, but I'm feeling dependent on it. And when I do that, the 15i's cancel. Negative 1 and negative 5 gives me a negative 6. Now I'm going to multiply 1 minus 3i times negative 6. So I'm going to go negative 6 times parentheses 1 minus 3 second I. And I get negative 6 plus 18i, which is a good thing because that cancels out, and I get a 0. I started with a 4th degree polynomial. I did double synthetic, so this is now going to be a 2nd degree. This is x squared minus 5x minus 6, remainder of 0. So the double synthetic division gives me a factor of that original polynomial. I'm going to put this back to my original page. I get x squared minus 5x minus 6 as the factoring. So what I have now is x minus 1 plus 3i, I can set that equal to 0. And x minus 1 minus 3i, I can set that equal to 0. And this, x squared minus 5x minus 6, I can set that equal to 0. I need to factor it. For this, I'm going to add 1 plus 3i to both sides. And that's going to give me 1 plus 3i for a 0. For this, I'm going to add 1 minus 3i to both sides. And that gives me x equals 1 minus 3i for a 0. And I knew those were zeros already. I didn't really need to do that. This is just confirming that. And this factors into x plus 1 times x minus 6. I'll set the x plus 1 equal to 0 and get x equal to negative 1. The x minus 6 equal to 0 and get x equal to 6. So the solutions to this problem, there's 4 of them. 2 of them I already knew. I knew that 1 plus 3i was the solution because that was given. And I know that conjugates are always solutions. So that 1 plus 3i was, 1 minus 3y was. And then minus 1 and positive 6 were the new solutions that I came up with. Let me make sure that 6 works, just to make sure that I haven't messed up. So I'm going to the original problem. I'm going to go 6 up arrow 4 minus 7 times 6 up arrow cubed. Can't see that. fight me. Minus 7 times 6 cubed plus 14 times 6 up arrow squared minus 38 times 6 plus 60. So that's just attempting to plug in 6 in for all the x's in the original problem. The only way this is, it should be minus 60. The only way I have 6 is correct is when I hit 0, hit enter, I get 0, which it does. I could do the same thing with negative 1. Put it in for all the x's, hit enter, I should get 0. I could do the same thing for 1 plus and 1 minus 3i as well. So that's 16 done. Let's move on to 18. And hopefully it's not this horrible. 18 looks horrible to me. I need double synthetic division again. I know that 3 plus 2i is a solution. I also know that 3 minus 2i is a solution. I'm going to do synthetic division with 3i, 3 plus 2i, and 3 minus 2i. And I'm going to be a little bit lazy here. The answer for my second synthetic division is going to have a square. I'm going to set that by itself equal to 0 to get my other two solutions. So there's going to be 4 solutions to this problem because it's a 4th degree polynomial. 2 of them I already have, and I don't really need to get as grungy as I've been, and I'm going to try to clean up my work a little bit. So I'm going to pull off my double synthetic division now. The result of my double synthetic division, I'm going to set equal to 0. It's going to have something with a square. It's going to give me my other two answers. So I'm going to start off with the 1, negative 14, 77, negative 200, and 208. And I'm going to start off, and I'm going to put 3 plus 2i in. But before I do this, I'm going to make sure I haven't messed up on this problem. I'm going to plug 3 plus 2i in for the x's. I'm going to go parentheses, 3 plus 2 second I, up arrow, 4 minus 14 times 3 plus 2 second I, up arrow, 3 plus 77 times 3 plus 2 second I squared minus 200 times 3 plus 2i plus 208. Hope to get 0. I might get something with the e. Oh, it gave me 0 perfectly. So that's absolutely a solution. So that means I need to be able to do this first synthetic division, use the result to do my second synthetic division. I bring down the 1. Multiply 3 plus 2i times 1. Anything times 1 is itself. So the first multiplication gives me 3 plus 2i. I'm going to combine the minus 14 and the positive 3 and get minus 11 plus 2i. Now I'm pulling out my calculator. I'm going to go 3 plus 2i times negative 11 plus 2i. So parentheses, 3 plus 2 second I times negative 11 plus 2 second I. And you can't see that, but I did that multiplication. And when I do that, I get negative 37 minus 16i. So I'm going to write minus 37 minus 16i under the 77. The 77 minus 37 is going to be 40. So I'm going to get 40 minus 16i under the 77. Now I'm going to multiply 3 plus 2i times 40 minus 16i. So I'm going to go 3 plus 2 second I times 40 minus 16 second I. And I get 152 plus 32i. To go under the negative 200, I just need to combine the negative 200 and the 152, and that gives me negative 48. I bring down that 32i. Now I'm going to multiply 3 plus 2i times negative 48 plus 32i. So I go 3 plus 2 second I times negative 48 plus 32 second I, and I get negative 208. So there's my remainder of 0. Ready to do my second synthetic division with 3 minus 2i. So I'm going to pull off the 1, the minus 11 plus 2i, the 40 minus 16i, and the negative 48 plus 32i, along with the 3 minus 2i, and do synthetic division. Bring down my 1, multiply. 1 times 3 minus 2i is 3 minus 2i. Nicely, the 2i's cancel, and the negative 11 plus 3 is negative 8. It's multiplication. I'm going to use my calculator for. I'm going to go minus 8 times 3 minus 2i. Don't really need a calculator for that, but it's safe. That gives me minus 24 plus 16i. 16i's cancel. 40 minus 24 is positive 16. Now I'm going to go 3 minus 2i times 16. So I do 16 times 3 minus 2 second I, and I get 48 minus 32i. Not that you probably could see that, but this thing's just fighting me tonight. Just can't seem to find a spot that works consistently. There it is, 48 minus 32i. That gives me a remainder of 0. The result of my synthetic division is the second degree polynomial. That, when I set it equal to 0, is going to give me my extra solutions. I don't really need to go through the full out factoring that I've been going through. So I'm just going to find this, which is x squared minus 8x plus 16, remainder of 0. I'm going to find out where this equals to 0 to get my extra zeros. This is rather well, this actually does factor. I need to factor this, and this, so I'm going to set that equal to 0 to get my extra zeros. And this factors actually into x minus 4 times x minus 4. And it only gives me one extra solution of 4. So in terms of the answers to this problem, 3 plus 2i and 3 minus 2i are zeros, meaning if I plug them in for x, I get 0, and also 4 is. So getting back to the problem, my answers are 3 plus 2i, 3 minus 2i, which I can get kind of without having to do a full-out factoring. And then the result of my synthetic division, because I started with a 4th degree polynomial, did 2 synthetic divisions, got a 2nd degree polynomial. When I take the result of my synthetic division, set it equal to 0, I get the extra 4. Make sure that 4 works by plugging it into the original problem. Go 4, up arrow, 4, minus 14 times 4, up arrow cubed, plus 77 times 4 squared, minus 200 times 4, plus 208, and it gives me 0, so it really is a solution. I think we just have one more to go. Yeah, we do. And it's a 3rd degree that I'm going to take down to a 1st degree. I know that negative 4 plus I is a solution, also negative 4 minus I is a solution. My synthetic division needs to get me one more solution, and the result of my synthetic division, my double synthetic division, I start with a 3rd degree polynomial, I do double synthetic division. The result of my double synthetic division is going to give me a 1st degree polynomial. I'm going to solve that to get my 3rd 0. Again, let me make sure that this answer actually works. So I'm going to go, just to make sure I haven't messed up, negative 4 plus 2nd I cubed plus 13 times negative 4 plus 2nd I squared plus 57 times negative 4 plus 2nd I plus 85, and I get this 1e to the negative 11. That, for my calculator purposes, is a decimal point, 10 zeros and a 1. That's close enough to 0 for my calculator. I'm going to call that 0. So I'll do this double synthetic division, and the answer for my double synthetic division I'm going to set equal to 0. So I'm going to start off by pulling off the coefficients of 1, 13, 57, and 85. I need to do negative 4 plus I and negative 4 minus I. It doesn't matter which one I do first. I do the negative 4 plus I just because it's there. I bring down the 1. I multiply. 1 times anything is itself, so I get negative 4 plus I. Combine the 13 and the negative 4 and get 9 plus I. That multiplication I use my calculator for. I'm going negative 4 plus I times 9 plus I. It would be a horrible nuisance to do this by hand, take me twice as long. That gives me negative 37 plus 5i. The 57 and the negative 37 give me 20. The plus 5i is just a plus 5i. Now I'm going to multiply. Sucks. Now I'm going to multiply negative 4 plus I times 20 plus 5i. So I'm going to go negative 4 plus 2nd I times 20 plus 5 2nd I. That gives me negative 85. There's my remainder of 0 that I'm hoping for. Ready for my second synthetic division with negative 4 minus I, and pulling off a 1, a 9 plus I, and a 20 plus 5i. my answer is going to be something with a remainder of 0. First thing I do is I bring down the 1. I multiply 1 times anything, and I'm going to get that. So I'm left with 9 minus 4, which is 5, and the i's cancel. Now I'm going to multiply 5 times negative 4 minus I. I can do that in my head, but heck, it's not that hard to use my calculator, and it's much safer. When I do that, you can actually see it. You get minus 20 minus 5i, which is 0. So I started with a third degree. I did double synthetic division. This is a first degree. This is x plus 5 with remainder of 0. To get the third solution to this problem, I take this x plus 5, set it equal to 0. Set it equal to 0. I just minus 5 from both sides and get negative 5 for the other answer to this problem. So this problem, because it's a third degree polynomial, I hope to get 3 solutions. I claim the 3 solutions are negative 4 plus I, negative 4 minus I, and negative 5. I already checked one with an I. Let me check the 5 to make sure, or the negative 5 to make sure I'm not doing bad things. So I'm going to go negative 5 up arrow cubed plus 13 times negative 5 squared plus 57 times negative 5 plus 85 says 0, so my answer is perfectly correct, and that's everything in this section. So there's just 2 styles of problems. The first style of problem is creating a function with a bunch of x minuses and foiling it out. And the second group of problems is doing synthetic divisions to solve equations that are equal to 0. And that one problem that I crossed out, it's just going to be dead. I'll just make some sort of comment in my notes that there's going to be no such problem. Otherwise, I'd re-record the video, and I don't really feel like doing that. So hopefully this is good enough to get you through the odd problems. I've already worked out all the odd problems, and they all work, so you shouldn't run across any problem that doesn't work, like the problem that I started and couldn't do because it didn't work.